Alright, hopefully this helps. I'm gonna try and be the Indian tech guy on YouTube today. I'm gonna show you how to get total resistance out of a parallel circuit and total current as well. And how we're gonna do that actually is by shrinking the circuit down and simplifying it, making each of these parallel resistances their series equivalent. And what this looks like is that. And as you can imagine, that's a lot less intimidating, a lot easier to work with, all that good stuff. So the first thing you do is combine all our parallel resistances. So as you can see, I wrote down that 1 and 2 are in parallel, and 3, 4, and 5 are in parallel, which is correct. These guys are in parallel, and these guys are also in parallel. So we're gonna shrink them down. So how you do that, this can be a little bit tricky, but as long as you put it into your calculator the right way, it's pretty straightforward. So what we're doing here really is just a whole shit ton of math to combine the resistances. But the most important part you want to make sure of, so this is, you can kind of ignore this. When you're given resistances, that's just how I learned. But this is how it actually goes in your calculator. So once you get your calculator in any given problem, like these are always going to be your resistance values. Like these are variable, but these brackets and the 1, that's always in the equation. So whenever you get resistance numbers, just put it in there. It's always 1 divided by whatever your resistance is plus 1 divided by whatever your resistance is. And once you get your answer from that, you want to put it up with the exponent of -1 plus each of your resistances. So our resistances in this case are 25 and 30 ohms. So you want to put a negative exponent on the 25 and the 30. So once you put this through the calculator, this bottom line here, it'll give you your final answer. There will be no need to touch it anymore. So this took me a long time to get a grasp on, probably like a week when I was in my first semester, and I was getting super stressed out too, because the placement of the brackets and the negative exponents are super important, and if you're not putting it in the calculator right, like it's super tedious and it'll keep giving you the wrong answer. So just really practice the shit out of that, and just double check your work. And to combine these last 3 resistances, it's pretty much the exact same thing, just with 3 variables. They call this reciprocal formula. It took me a bit of time to get a hang of, like a week, but once you got a hang of it, like it's not really something you forget. Well, I forgot it until today, but once I checked my notes, it came right back to me. So pretty much, we got a smaller resistance value here and a smaller resistance value here, and that's just because it's the combined total of the series equivalent, I guess they call it, of these resistances. So once you got the equivalent resistances, this is what the circuit's looking like, and it's a lot easier to deal with that way. So you can add up these series equivalents and you'll get your total resistance. In this case it's 20.11 ohms, and yeah, that's your total resistance. And from here you can find your total current, and I went ahead and did this on the other side. So total current is equal to each of the branch currents. So in order to find total current, you just gotta find current in here and current in here, and once you only got 1 resistor on each side, it's pretty easy. So we know I equals V over R. So I put the source voltage in this question to 100 volts. And our R1 that we just determined, this is our series equivalent, 13.7. So 100 divided by 13.7, that tells us our branch current up top is 7.3 amps about. So that's along the top there. R2, we do the same formula, and we get 15.6 amps, and add them together and you get 22.9 amps. And if you want, I can show you how to get like voltage drops across each of these, or total branch currents out of each of these without simplifying the circuit too. Just let me know.